title, How to Succeed with Deep Tech. Wow. But I will start to explain what Ekkono is and what we do, so you understand where we're coming from and why we're working as we do, and how we're trying to succeed with our business. So, Ekkono is Esperanto for cognition, and that's what we try to bring to the Internet of Things. We want to make all connected things smart. And we do that by providing an embedded machine learning library for the Internet of Things. So we actually produce code and algorithms that's supposed to go into different IoT things. And it's a wide variety of applications, from windmills, electrical cars, power tools, boats, robots, whatever, right? So a very large range. And we work with machine learning. That is a subfield of artificial intelligence, where it's really learning from examples. So reading the data and then finding patterns that we can use for optimize the machines or do predictive maintenance, stuff like that, right? So machine learning, we do, more specifically, we do edge machine learning, which differ from the typical machine learning that is done today in the cloud, like data analytics. And the basic assumption for machine learning in the cloud is that you have a set of devices that have something in common. So you send the data up to the cloud, and then you do some data analytics, and then maybe you can explain the fuel consumption, or even better, the driver's effect on the fuel consumption. However, in reality, it's a little bit more complex than that. The devices will have different configurations, and they will act in different environments, and even the configuration may change over time. And that will make the problem of sending the correct data to the cloud very complex. So what we do in Ekkono is that we put the data analytics, the AI, the machine learning, on the devices. And why do we do that? Well, if we have one model, one AI per device, we only need to learn what is normal for this device, and then explain how this driver is affecting the fuel consumption. We don't need to explain the difference between them, right? So we're simplifying the problem with divide and conquer. The downside is, of course, that if you're residing on a truck or on a heat exchanger or something, you will have less computer power. And that's what we really have put so much effort into our library, to make it efficient in terms of memory and CPU consumption. So there's, of course, many things you can do in the cloud. We know that now, and it works perfect for many stuff, especially if you have a homogeneous fleet of devices. However, there are also many cases where it's better to do it on the edge. So edge computing and edge machine learning is a complement to the cloud, really. First, you sometimes have the data volume, that you have so much data that it doesn't really make sense to send it to the cloud. I know that a modern ABB power substation delivering electricity can generate up to 5 gigabytes per second. And you don't want to send that to the cloud, because it doesn't really make sense. You often end up sending averages instead, but then you lose the details of the data, right? You don't get the good data. And other times you have, of course, the latency, if you want to go to the cloud and back. And if you want to control an engine to lower the emission and stuff like that, maybe that round trip will be too slow. And of course, you have the connectivity issue. There are many places where you don't have a good connection, and then you will have problem with doing your data analytics if the data doesn't arrive properly or not at all. Another reason to doing it on the edge is data integrity, and not just GDPR. We see that many of our customers, is big Swedish industrial companies, creates machines, and their customers doesn't want to send the data to the manufacturer, because that's their golden data. That's how they run their business. But they still want to be able to have a warning light if the machine is about to break, or when to be able to do the maintenance on it in a scheduled way. So by doing the analytics on the edge device, you can just send the need for maintenance to the cloud, and then in that case keep the integrity of the data. It's also more energy efficient. So if you have a device running on battery, you can save an order of one magnitude of energy consumption by doing the calculations on the device instead of sending it via Wi-Fi to the cloud. And then, as I mentioned before, it's a great way to do individualization, not doing one model for a whole fleet, but actually for each specific device, since all IoT devices have so different environments. But it's a complement. Some things you do in the cloud, some things you do better in the edge. And when we're speaking edge devices, it's everything from the gateway tier here, where you can actually have a really powerful PC, all the way down to at least the constraint tier here. Maybe we can go down. Could in practice probably do it on the sensor tier, but it doesn't really make sense doing data analytics on just one sensor. So we work down all the way here. Maybe we have 2 megabytes of RAM and a small CPU, right? So that's the trick of doing the AI so efficiently that you can running it there. That's why it's not everyone is doing that today. But it's possible with the right tool. So our business model, our goal is to be a good old-fashioned product company. So we want to sell our embedded software library for machine learning on the edge. So we license code. And the business model is that when our customer produce their products with our software on, then they pay a license for that device, and it's perpetual. So it's one-time payment. So we don't earn money until our customer earn money. So we're aligned to make them succeed. We want to help our customer to be self-sufficient in data-driven innovation. Because if they don't do that, if they don't grow, we don't grow. So we have aligned our goals with them. So then the question is, how do we succeed with this? How should we go there? And of course, we can start to turn to design thinking. Well, innovation is happening here when we combine all these three aspects we're speaking about today. And I hadn't thought about this before I got the question to speak here. Are we actually doing this? And I started to reflect on that, and I say, yeah, naturally we're very heavy in the tech thing with our algorithms and tools, and in the business, because if our customers are not happy, we're not happy. But we're also quite focused on the human versus technology field here, both in the human-computer interaction, since that will be in the field, but also in that a core value for our company is sustainability. We want to do good with our solution that we provide. So we, like the tip from the previous speaker here, we include the UN agenda of sustainability in our quotes, and say how the project will contribute to the different goals here. Because it's very important for us to leave the world a bit better than it was before. So that's another part there. But we didn't start there. We happened there. Okay, we're a little bit all over the place, and we hope we're in here. But how? Why are we there? Well, when we started this, and that was not 350 years ago or 10 years ago, it was actually 3 years ago, we realized, okay, we need a very structured process if we're going to be successful. We want to make sure we innovate the right thing in the right way. So we started to create supporting tools. So automate as many steps of the AI as possible. Have templates for delivering different projects, because we're going to be doing a lot of different projects with a lot of different applications, right? From a battery to a stone crusher to I don't know, you name it. We've been working on so many different stuff. So we want templates for that, and we want to revise the tool and templates after each project. But we want to be a product partner. So we want to be a product company. So we can't do all this ourselves. We don't want to do the consultant hours. And we can't be experts on everything. So we work through partners, and our partners needs to be able to succeed or help our customer with data-driven innovation. So we need all the things that now in the beginning we have been doing a lot of projects ourselves with our knowledge. but we want to be able to deliver that knowledge either directly to our customer or to our customers through our partners. So the inherent knowledge here that we gained, we need to be able to transfer that. And how do we do that? Well, then we turn to an old method, the cross-industry standard process for data mining, or CRISP-DM, which is a very structured process of how to succeed with data mining projects. And what is data mining? Well, it's the automatic or semi-automatic process of finding actionable information in large quantities of data. So machine learning is used for performing data mining. The difference here is that you want to find some actionable information. Which campaign should I send to each customer, stuff like that. Not really controlling a machine. But it has a lot of common. And it was conceived in 1996 by IBM, or a company that IBM later bought, and some other big companies. And it was also developed in the consecutive years by over 200 organizations who were looking at the projects that they have been doing and see which one succeeded and which one did not, and what did we do in common, right? So 72 pages of small print describes how you should work in this kind of data mining or machine learning projects. And they stress, first, business understanding. Start with defining the value you add with your innovation. And to do that, they also stress that you need to get people from the whole organization, from management, from sales, and from engineering. Because if you just look at one of these aspects, you get an engineer who will invent a super cool thing that no one wants to use, or you get a sales guy trying to do something that is impossible, or you end up with a product that no one wants to use, right? So that's one thing. They also say that you need to state the business success criteria. When is a solution good enough to be able to sell it? Otherwise, you will end up in some rat hole, just refining your solution and never becoming ready, right? So that's the main part here. And then you have a data understanding. When you look at the data from the sensors and stuff and see you understand that. And then you start to prepare, and then here is just really techy things. How do you prepare the data for the algorithms? And how do you model that? And then you come to the evaluation, and this is again, then you evaluate against the business success criteria that you set up here. Was it good enough? Yes, then we can take it to deployment. Otherwise, we need to take another looper. And so in an agile way, doing this fast several times. And you, of course, can go forth and back as well between this one. But doing it in a very structured way, so you don't miss any important stuff here. The problem with this one is that it was invented in 1996. The world looks a little bit different now from then. And we want to do this for machines and not for just actionable information. So we took this method and we've been refining it over the years now, or over several projects, to something that looks like this. First, we added the sustainability goals. So you actually consider them both in the business understanding and through the evaluation. But more importantly, if you're going to actually develop a product with AI or machine learning on it, you don't stop when you have that worked nice in our proof of concept or in our MVP. Then you need to implement it in integrate it in an application. You need to ensure the quality over a larger set of devices and units and test. And then you need to deploy it and have a plan for deployment and maintenance of that deployment. So we're working continuously with updating this process and putting our experience in these new steps of this method. And then we're delivering documents and supporting guidelines for our partners so they can work according to this project. And everything that they learn, we take back and try to enhance this method. And then, of course, you can think again then, okay, how did we come where we came? And what does they have in common, this CRISP-DM or the refined CRISP-DM and these three aspects? Well, if you think about it, which I did, and then I did some PowerPoint magic, high tech, I saw that, of course, we're a lot here in the intersection between business and technology, since the aim is manufacturing. And we're purely tech in some parts, but we're actually all over these three aspects. And I don't think it's by a chance that they got there. I mean, there was these 200 organizations looking at, I don't know how many projects, and they were saying, okay, these are the things that you need to do when you develop your products, right? And I'm happy to see that it's actually in there. I hadn't reflected about it, but it's definitely. And when I reflect, I see the importance of these steps. And definitely this business understanding, to start with that. How do we add value to our customers? If you don't do that, you're lost to start with. So to summarize this, Edge Machine Learning, it's a powerful complement to cloud analytics, and we provide an embedded machine learning library for IoT. But to do data-driven innovation, you require a structured approach, and our way of refining Crisp Team is one of those. And we see that all of these three aspects are inherent in the process. And I think that's why it's been very successful for us. Thank you.